Hello, Algebra 2 students, for Miss Bell. If you missed class today and you need to go over the 2B test review for tomorrow, I have it here for you. And so for number 1, it says, by examining past temperatures, it's possible to calculate the probability that a school wins their first game in the National College Basketball Tournament. What you're doing is you're just looking at these X and Y values. And so we have to think about the change in Y over the change in X is going to give you your answer to this one, because it's going to ask what does the slope of the line represent. So the slope of the line is going to be this. Remember, we're thinking about y equals mx plus b, where m is the slope. Okay, b is going to be the I'm going to talk about number 2, the y-intercept. Okay, so the only one in that is it's going to be the change in percent chance of winning the first game for every change in rank. Okay, so it's going to be B, because we have our X and we have our Y values. So it's the change in the Y values over the change in the X. So I mean, you could select, take 91 minus 47 over 3 minus 9, something like that, or the other way around, taking your y2 minus your y1 over your x2 minus your x1. And that's going to give you B, the change in percent chance of winning first game for every change in the rank. So that's going to be what the slope represents. For number 2, you're looking at this chart right here, and you have your X and your Y values. They want to know the y-intercept, this right here. Now, this right here is going to be, what your y equals if x equals 0. So the y-intercept, remember, is where it crosses the y-axis if you were to graph this. So it would cross the y-axis at 4.18. So, somewhere 1, 2, 3, 4, just a little bit above 4. That's where this line is going to intersect the y-axis, is what I'm talking about, is at 4.18. And it's a positive slope. It's almost like a half, so that means it's kind of shallow. So the line's kind of like this, if we were to graph these, okay? That y-intercept is the average electricity consumption for daily average temperature of 0 degrees Fahrenheit. So our x values, these are our x values up here, y down here, sorry. Okay, so if we had a temperature of 0, where x is going to be 0, then that's where we get that y-intercept, 4.18. A lot of explaining there. Sorry about that. Okay, for number 3, talking about this graph and this equation, and I'll let you read through that. And in this equation, they're asking what would be the wind speed of a hurricane with air pressure of 946 kPa, which I'm going to just plug that 946. That's the air pressure per speed in knots, nautical miles per hour. I plug that in for my X value, and all you do is then work the problem out. And I wrote it kind of ugly here. It's actually y equals negative 1.06 times my X value is 946 plus 1100, okay? I work that out, and you're going to get something like 97.4 something. We round it off. It says round your answer to the nearest knot, and that would be 97 knots. For 41, we are going to plug 97 in for the temperature, because it's asking what would the daily average be, electricity use, if it's 97 degrees. So that would be our X value, because these are X's, these are our Y's. And so I'm going to plug in 97 for my X value, and I just work the problem out. I round it to the nearest kilowatt hour. 52.5 rounds up to 53 kilowatt hours. Okay, going on to these. These are a lot easier, a lot less reading. If it's inside, if you have something going on inside the parentheses or absolute value bars, whatever, remember it's going to be horizontal, and a negative inside is going to be to the right. So that is going to be D. That means from the vertex from the origin would move right 2. If it was a +2, it would gone left. That would be C. This is X plus 2. Absolute value bar, sorry. This one would be X absolute value bar plus 2. This one would be negative X minus 2. I won't do that for each one because this would be very long. All right, remember on the inside it's left, and it's going to be horizontal. It's horizontal. This one happens to be left because it's +2. And over here it's vertical. So vertical up down, that means it's going to be down because it's negative, and that one is going to be right here. For 7, remember if there's a negative in front of the absolute value bars, that's going to reflect over the x-axis, so it's going to flip it over, reflect it. And then this is going to be horizontal because it's inside, and this is to the right because it's negative, and that is going to be A. Well, we've got a lot going on. Number 8, we have a reflection, so it's flipping it over. And then we have a horizontal left and a vertical up. And so your answer there is going to be C. All of these, by the way, have the parent function of this. This is where it starts. So we're comparing all of these, 5, 6, 7, 8, to this. This is just where y equals absolute value of x. Okay, here's our y-axis, here's our x-axis. So we count, from the vertex, how it moves. And how it moves depends on whether we got a horizontal shift, a vertical shift, a reflection, whatever. Okay, number 9. Comparing this to the dotted line, what we're looking at is just, look kind of where it is at the origin. Notice that it goes down 2 and goes left 1. Number 10, notice this one went down 1 and left 2. Number 11, notice that this one went up 2. But then, the way I figured this one out, we have a stretch. It gets skinnier, a stretch. Why it's not this and why it's this. If you take a look at this point and this point, you can kind of see a slope going on here. And this is going up 2 over 1, even though I know that these are, by 2s. It's 2 times this slope, which is just going up 1 over 1. So that would be 2 times. If it was a half, it would have went up 1 over 2. It would have been out here. Up 1 over 2. That would have been a half. Okay, and the same reflected on the other side. But this is 2. So it's going to be a stretch. And then the +2 means that it's going up 2. Number 12. We have a reflection, so it's one of the first ones here, reflection across the x-axis, and then it moved up 2, so it's +2. This one would have been, it moved left 2, so it would have gone like back here, and just would have been like that. But this is plus 2 on the outside of the parentheses, so it's up 2. Okay, real quick, 13. This is going to be reflection across the x-axis, and then because it's on the inside, it's translating right 3. This one, remember when you have a number out in front of the absolute value bars or outside the parentheses, and it's between 0 and 1. If this number, n number, is between 0 and 1, it's going to be a shrink. Okay, it's not going to be the expansion or stretch. It's going to be a shrink or compression. They may use that word. It's good vertically by a factor of 1/3. That was wrong. It should say 1/3 there. And it translates right 3 units because it's a minus 3. It goes right. And lastly, number 15, this one, we wanted to stretch vertically by a factor of 3. So we're going to multiply the outside by 3. That's the only one that does that. And then it's going to translate up 2 units, and it goes up 2 units. That plus 2 has to be on the outside. Okay? This would be a compression or a shrink. Plus it would have to be on the outside. So it doesn't make any sense. So B is your answer for that one. Hopefully this helps. If you need more help, Zoom me. I got nobody there. And good luck.